reference angle. Reference angle is always referred to the first quadrant. So it's got to be between 0 and 90. The reference angle, if you draw a picture, is always made with the x-axis. And the best way to make sure you get it right is you need to take the reference angle and you subtract 180, or is it 180 minus the reference angle? Is it 180? Sorry, is it 360 minus a reference angle? Is to draw that picture. 96 degrees. Again, I just don't like memorizing formulas. I just know that if I have a 96-degree angle, that's past 90, it's in quadrant 2. There's 96. The reference angle is on this side. It's between this x-axis and that angle right there. This is your theta prime, the reference angle. So it's going to be 180 minus 96 degrees. So 180 minus 96 degrees is going to be 84 degrees. Any problem with that? And yeah, that's multiple choice. Only one of those choices is between 0 and 90. Your quizzes and tests are not going to be multiple choice. Your final is going to be multiple choice. But this won't. Now, on number 2, there are 2 angles that are between 0 and 90. And you also have one that's also, between 0 and negative 90, but that's not a reference angle. So the negative 35 is out. So you got 35, 55. There I go again. Draw a bloody picture. I'm channeling my, my UK self. Okay. So negative 125 degrees. What quadrant is that going to terminate? Quadrant 3. Good. Quadrants matter. So there's negative 125 degrees. So the reference angle is this angle that's made with the x-axis. So just think of it as how much more do you need to make 180, or 180 minus a 125. There's my 55 degrees. So the sine, cosine, and tangent, the sine of negative 125 degrees, the cosine of negative 125 degrees, the tangent of negative 125 degrees is going to be referred back to the sine of 55 degrees, the cosine of 55 degrees, and the tangent of 55 degrees. Now, they're not equal. 55 is in quadrant 1. The sine, cosine, and tangent in quadrant 1, everybody's positive. The actual negative 125 terminates in quadrant 2. Quadrant 3. What is the only positive ratio in quadrant 3? Tangent. So the tangent of negative 125 degrees is going to exactly be the same as this one. This is a positive ratio. It's going to be a big punch into calculator. You want to get a negative. Sorry. I know. Chevy, you know who Chevy Chase is? Yeah. He's one of the original members of Saturday Night Live that started back in 1975. And he's been in tons of movies. And anyway, he's a comedy icon, if you ask him. He was on community for a long time. Okay, anyway, one of the things that he would do during Saturday Night Live when he would mess up his live, he would say, togo. Because it's hard to say 3 times in a row. Togo. Yeah. That's positive in quadrant 3. This would be a positive, so I would look this up to give you that answer. Those signs. This is quadrant 3. That's quadrant 1. So the answer to this is just the opposite of that. I would look up the cosine of 55. Remember that I'm in quadrant 3, so I do better make sure I put a negative in front of that answer. That's how you use a reference angle. 55 is in quadrant 1, so that's going to give you a positive ratio. This is in quadrant 3, so the sign of it is a negative number. So I would need to take the opposite of that answer. Just got to remember to put a negative in front of it. And that's the most important thing is before you even begin anything else, put your sign, get your sign there. Okay. We have there's 764. So there's 2 angles that are between 0 and 90. So those other 2 are out. 764. We know 360 degrees in one revolution. Another 360 is 2 revolutions. 360 plus 360 is 720. 360, 720. 64 degrees is just another 44 degrees past the x-axis. And that'll give me 764 degrees. Not bad. The reference angle is this angle right here, and it's just 44 degrees. The visual helps me. I don't have to go through the whole trouble of going, all right, that's my angle of 764. Let's find a coterminal angle. Subtract 360. There you got 4, you got 0, you got 4. I can still subtract another 360. And that's a 4, and then a 1, a 3, and that's a 10, and that's a 4. And I get 44 degrees. There's my coterminal angle that terminates on the same terminal ray, terminal side, as 764. And it just so happens that it's also between 0 and 90, so it's also the reference angle. So that's my favorite prime. Okay. And at 1395, automatically, the only special angle that ends in a 5 is your 45 degrees. So 1395 has got to refer back to some kind of 45 degree angle. 30 doesn't end in 5. 60 doesn't end in 5. 0 and 90 don't end in 5s. So if it ends in a 5, it refers back to 45 degrees somewhere. We just need to know what quadrant is that in so we get our signs right. If it's about 45 degrees, right now I can tell you that this is going to be 1 over square root 2, this is going to be 1 over square root 2, and this is going to be 1. Or if you rationalize square root 2 over 2, square root 2 over 2, and that's still 1. You flip these over, you get square root 2, you get square root 2, and you get 1. But we got to make sure we have our signs right. So 360, 720. 720 plus another 360 is 1,080. $360 more is 1440. 1440. So that is 4 revolutions. 1440 if we go around 4 times. Which means that's too big. We passed 1,395. So if we back it up 45 degrees, this right here is where 1,395 terminates, and it terminates in quadrant 4. What is the only positive trig ratio in quadrant 4? Cosine. Okay, cosine. Remember, we've now defined the cosine of angle theta as the x-coordinate over the radius, x over r. The radius is always positive, always. In quadrant 4, the x's are positive and the y's are negative. So cosine being x over r, you have a positive x over a positive r, cosine is positive. Sine would be y over r. The y's are negative. Y negative over a positive r, negative over positive, that's a negative sine factor. Tangent is y over x. Y's are negative, x is a positive, negative over positive. Tangents are negative in quadrant 4. The reciprocals are the same sign as the originals. So sine is a negative, cosine is positive, tangents are negative. Cosecant, the reciprocal, would be a negative, secant's a positive, cotangent's a negative. All done. Technically, I should have done my signs first. I should have figured out what quadrant 1,395 is in, so I know my pluses and minuses, and then I'm going to go find what reference angle that is. But I wanted to really jump on the fact that the only time where reference angles are 45 is because it's got to end in the 5. If you're in radians, it would be divide by 4. And again, this is for exact values. Exact values. And I'm going to throw in one little, fine print for now. When we get to other trig formulas, there are ways to do pi over 8s, and that's going to be a pi over 4 when you get done with it. But that's so I'm going to post this tonight, and I'll send as an email, I'll post it. But this is the warm-up. This is the warm-up. Basically, it looks like this. All my ratios here. You're given an ordered pair, x and a y, find all 6 exact values. A wheel is rotating 840 times every 6 minutes. Through how many degrees does it rotate in 20 seconds? Now that's not 5.3, that's 5.1. Guess what? You're going to need to know 5.1 when it's time to take the test. So how is that going to apply to your quiz? Well, you'll find it. You're given a secant value. Hey, don't forget, if you know secant, you know cosine. Don't forget. And it terminates in quadrant 3, so you should know your sine. Find the other missing trig values. And then a little word problem. Okay. So I'll send that, post it, and send it as a warm-up. That's what we do. We left out in 5.3. And 30. Look at my picture. Anybody not get a colorful unit circle? Now, I also handed out 0 to 360 tables. That's why I have to see the picture of the wall. Oh, so many damn things. That sort of thing. So that was the last thing we did. We filled in that table. Which you have the major table, you have the 0 through 360, and that's good practice. I mean, it's important practice, but I told you the other day, it's 0 through 90 that you need to know by heart. So I made this, which is just 0 through 90. Now, you can use this on any quiz you want. You don't get to use it during tests. If you can fill this out without thinking twice, without needing to draw a circle, without, having to, like a math hack. If you can fill it out as easily as you know that 2 times 2 is 4. You made leaps and bounds about knowing the rules. It's like conversational Spanish, French. You're doing conversational trig because you're able to interpret all of the special angles in degrees, in radians. Okay. all the special angles, 0, 30, 45, 60, 90. Don't forget about 180, 270. But 180 is just the other side, okay, for pi. And 270 is just the other side for 90. And all of the trig ratios that go along with it. Those are all from special right triangles. Eventually, you're going to take, and it's not in this chapter, it's in the next unit 5B. You're going to take a memory quiz that looks like this. And I hope I left it up, and I probably didn't. This is the practice memory quiz. And it's just like a math fact. I give you 10 of them. I give you 10 random angles in either degrees or radians. I'm going to have to make it smaller so it'll fit. Okay, so you can, so let's just, so you can see what's going on. And you gotta fill in the squares that aren't blacked out. So for 4 pi over 3, off the top of your head, you gotta know the exact sine, cosine, and secant, no decimals, but the sine of 4 pi over 3, or 4 pi over 3 is in quadrant 3. So sine is negative. That's a 60. So that would be negative square root 3 over 2. Cosine would be negative 1/2. And secant would be negative 2 because you flip over the cosine. Okay. So it's like a math thing. I'm going to give this quiz to you when we get to 5B, section 5B, not class 5B, section 5B. And I'm going to let you take it twice. If you like your first score, you're done. But if you don't like your first score, then I'll give you a second shot at it, and I'll keep the better of the 2 scores. Okay. That's how I usually do the memory quizzes, because sometimes, it's like, all right, it's not an easy thing for some people. I get it. Because you're forced to memorize and know things as opposed to work them out, which is what I always like to do. But this is part of knowing what you're doing. And it will pay off for you in the long run. And if I ever see you in 10 years on the street, I'm going to ask, what's cosine of 5 pi over 4? You better say negative 1 over square root 2. So I'm going to go with that example. We'll go with homework. Homework of the left time. Trig identities. I have a different take on that, so when we go over homework, I'll talk about that. Function calculator, that. Trig function with real numbers. And I'll come with this homework example. But these are just examples. Okay, periodic. A periodic function. And they're doing this right now because in section 5.4, we do graph. We graph the sine curve, we graph the cosine curve, we graph cosecant, secant, tangent, cotangent, graph everything. I take the graphing out of this for the first test, and then you can focus on graphing apart from this. Try to make it separate. Definition of a function periodic when there exists a positive real number c, positive, so t plus c. If I plug in some number bigger than 0, and I add it to t, I get the same y value up. So if I plug in, so if I have like f of 0, and I get 4. And then 0 plus 2, I get the same y value as f of 0. I get 4. The y values are the same. So it's periodic because it repeats itself. Okay. When you have a period, it's about a cycle. A cycle of things happening all the time, all the time, all the time. It repeats itself. So as you go around the circle, at 45, you get square root 2 over 2. Here for sine, and then here you get sine of 90 is 1. Sine over here is negative, still positive square root 2 over 2. Sine at pi is 0. Sine at 5 pi over 4 is negative square root 2 over 2. Sine at 3 pi over 2 is negative 1. Sine at 7 pi over 4 is negative square root 2 over 2. And then sine at 0 is back to 0. And then if you keep on going around, we're back to the sine of, that would be 9 pi over 4. Sine of 9 pi over 4 is going to be back to 1 square root 2 over 2. Okay. 10 pi over 4 or 5 pi over 2, this is going to be back to 1. So the y value just keep repeating. That's a periodic function. Periodic function. You know how the tides come in? You can measure the tide with a periodic function. They basically follow a sine curve. The rising of the tides and the lowering of the tides based upon the gravitational pull of the moon is just a sine curve. You have high tide, and then you have a lower tide. High tide and lower tide is a sine wave. Okay, this was the last trig identity on your list. That list of trig identities. These guys. The even and odd trigonometric functions. Now, in Math 3A, we cover even and odd functions. So that means in chapter 1 of this book, we do definition of what's an even, what's an odd function. Don't worry about that. Here's what you need to know, because this will make better sense. We're not going to look at it from the even or odd perspective. We're going to look at it from a trig identity perspective. Cosine of the opposite of t, negative t, is equal to the same as cosine of t. I'll show you the picture in a minute. Whatever cosine does, secant, the reciprocal, behaves the same way. Cosine depends upon which of the two ordered coordinates, the x or the y. Cosine is it the x over the r or the y? It's the x over there. Cosine is the x. Sine is y's. Sine is y, so cosine is x's. Okay, cosine is x's. When you picture an angle in quadrant 1, in standard position, the adjacent side, cosine being adjacent over the hypotenuse. This point on the circle, the x coordinate, the y coordinate of that point on the circle. Well, the x would be how far to the right did you go? It's the length of the adjacent side. The y value is how far up did you go? It's the length of the opposite side. And the hypotenuse is the radius. So the cosine of theta is now defined as the adjacent side is now the x coordinate, and the hypotenuse is now the radius of the circle. For any point. Okay. And the sine of theta is the y coordinate over the radius, and then tangent is the y coordinate over the x coordinate. That way we can find the sine, cosine, and tangent of any angle in all the quadrants. So the cosine, and I'm going to use theta instead of t so we understand a little bit better as an angle. The cosine of negative theta is exactly the same as the cosine of positive theta. What is negative theta versus positive theta? What does that mean to you? Yeah, which way, what direction the angle goes. If the angle is a positive angle, you're going to open counterclockwise from the initial ray. You're going to open counterclockwise. If it's a negative angle, you go down. You open clockwise. So if you have a positive theta, you're opening up counterclockwise, and if it's a negative theta, you would open clockwise, negative theta in that direction. Since the thetas are the same amount, one just goes up, one goes down, the x coordinates, whatever this x is at this point, it's near, down here, it's going to be the same x. This x is the same there as it is here. The y's are different. The y up here is a positive y, but the y down here would be the opposite of that y. Because it's down below it. It's, on the other side of the x-axis. It's a negative number. Does that make sense? If cosine is the x's, no matter how far you go, the cosine of theta here is that x over the radius. It's this x over the radius. It's the same x over the same radius. So it doesn't matter what direction you open up that angle, you're getting the same x over the same radius. So the cosine of going in this direction is the same as a cosine going in that direction. Even if you end up all the way and open up an angle all the way into quadrant 2, there's your theta. Well, negative theta would have to open up the same amount, but it would have to open up into quadrant 3. And that would be your negative theta. The x over here is the same x up there as it is down here. Now, whatever that x is, it would be a negative number. Maybe it's -5 there, it's -5 here. So they're the same x's, maybe they're negatives. Up here, that's a positive y. Down here, it would be a negative y because you're on the other side of the x-axis. It's a reflection across the x-axis. But the cosine, that negative x over the radius is the same as this negative x over the radius. Therefore, same cosine, whether you open up into the first and fourth quadrant, or you go all the way to the second and third quadrant, or even if you went all the way, if this blue went into the third quadrant, then this red would go to the second quadrant. You still have the same x's over the same radius. Cosines would be equal, therefore secant is equal. The other ones have opposites. When you do sine, the y is an opposite SIGN, sine. When you go up, this y is a positive y for positive theta, but when you go down below, it's the same number, but it's the opposite sign as that y. So the sine of negative theta opening down is an opposite y of that y. So it's the opposite of the sine of positive theta. You just change sign because you're in the other side of the x-axis. You're on the other side of the x-axis. I don't want people to think, and this is what people do think, oh, you just factor out the negative. No, it's not sine times negative t. If it was sine times negative t, yeah, you can factor out a negative for that multiplication. It's a function. It's sine of the negative. You're taking the sine of it, not time it. So you're not factoring it out. Okay, that's not why this is there. It's because of the direction of the angle and how it's open. When you open up, that positive y in the opposite direction to negative y. If you go to quadrant 2, it's still a positive y. Down below, it's still on opposite side. And therefore, tangent, the tangent of negative theta would be the sine of negative theta over the cosine of negative theta. Because that's the definition for tangent negative theta. And we just showed you that the sine of negative theta is negative sine theta, and the cosine of negative theta is the same as positive cosine theta. So now you have a negative over a positive, and that's how we get negative tangent theta. The tangent of negative theta is the opposite of tangent theta, which is that identity. Okay. Remember, we don't just make up what we hope it is in mathematics. Because if we were just going to make this stuff up, then we would just say, all right, if it's a negative, then this over here, we'll make that a negative. So that looks easier to remember for all of them to just be, if you do one negative, then let's make all of them just be negatives. Oh. Okay. Make it make sense. Questions? One through 12 all. Let me just refresh my memory to do that. Did I do any of these? 1 through 12 all or 13, 39 all? Did everybody allowed? Did I? No. So 1 through 12 all, let's just take a look at some of these numbers 1 through 6. If theta is an angle in standard position, that means opening from the x-axis opening counterclockwise. XY is a point on the terminal side of angle theta, and the radius r, which is the square root of x squared plus y. Does everybody understand why r is equal to the square root of x squared plus y? I know I did not talk about that. When you have the circle. Now we really haven't hit on the unit circle. We've used it, but we haven't talked about it. We're talking about any radius you want. Radius could be 12, could be 1, could be 0.5. It just has to be bigger than 0. So you have a radius, you have a point right there, which is an x comma y. You make a right triangle. So when you bring down the perpendicular to the x-axis, always with the x-axis, this length is x, this height is y. So you have your right triangle. The hypotenuse squared, r squared, is equal to x squared plus y squared, the two legs squared. Is that right there? So the reason why the radius is the square root, takes the square root, the radius is the square root of x squared plus y squared. No, that does not equal x plus y. Doesn't work that way. You have to have a product of two squares to undo the square, not a sum. For instance, the square root of 9 plus 16, does that equal square root of 9? Square root of 16? Does that equal 3 plus 4? Because if you think the square root of x squared plus y squared is just x plus y, then this would have to be true. Square root 9, just x, square root 16 is 4. We know this is 25, and the square root of 25 is. So is the answer 7 or is it a 5? Or is it both? Can I have two answers for one thing? Hey, it's America. We can do anything we want, right? It's neither. Hey, we've got 4 things. God darn it. Five or 7? Okay, thank you. I'm kind of worried, you know. I want to see anybody checking on a calculator. Yeah, you can't just go like that. That doesn't work. If it was the square root of x squared times y squared, that's x times y. Okay. So the sine, what is the sine based on all that information? Y over r. Tangent, y over x. X over r, that's your cosine theta. R over y. The secant? Okay, cosecant. Cosecant theta. Secant of theta would be the reciprocal of cosine. So r over x. And I have y over x, there's x over y, so this must be cosine. And you can see they're trying to give you left side versus right side all the time, or right side versus left side. Now, on 7, the answer for 7 and 8. A function is odd when you take f of negative t and you get the opposite f of t. That's an odd function. That's the actual definition for odd. That is not going to be part of this class. That's math 3A. They got to worry about it. And this is an even function. When you do f of negative t and you get the same y value. F of t. So that means cosine is an even function and sine is an odd function. Tangent is an odd function. What do you call the acute angle formed by the terminal side of an angle in standard position and the horizontal axis? A reference angle. Okay. Acute 0 to 90. With the x-axis, horizontal axis, reference angle. What quadrant is cosine positive? So I know we talked about how all students should be taking calculus. All of the trig functions are positive in quadrant 1. Counterclockwise, the sine and cosecant, the sine function is positive in quadrant 2. In quadrant 3, tangent and cotangent. In quadrant 4, cosine and secant. So what quadrant is cosine positive? Quadrant 4. Oh, thank you. Quadrant 1, I guess I was not thinking. Positive quadrant 1. And whenever you're asked a question and the answer is a quadrant, the answer needs to be Roman numerals. For which of the quadrant angles 0, power 2, pi 3 pi/2 is the sine equal to 0. So we know sine theta is y over the radius. So sine would equal 0 when what equals 0? Radius could never be 0 because if the radius was 0, first of all, you're divided by 0, but also second of all, if the radius is 0, then you don't even have a circle. Because if the radius is 0, you're not leaving the order. So in order for sine to equal 0, y over r, what has to be the 0? Well, the y. So the only place when y is a 0 is on the x-axis. Over here, x is whatever x is, but y is a 0. And over here, x is going to be the opposite of that one because it's on the other side. And the y would be a 0. So any angle that's on the x-axis, 0, 180, 360, 540, 720, or in this case, pi, right, 0, pi, 2 pi, 3 pi, 4 pi. That's all in there. Sine of 0, sine of pi, they're both equal to 0. Is the cosine of 170 equal to the cosine of 10? Is the cosine of 170 degrees equal to the cosine of 10? What quadrant is 170? Quadrant 2. What sine is the cosine in quadrant 2? Negative. So would a negative answer be the same as quadrant 1 cosine of 10? No. They'll have the same number. They will have the same ratio, the same digits or whatever. But in quadrant 2, this cosine of 170 degrees has to be the opposite of the cosine of 10 degrees because that's in quadrant 2 and that's in quadrant 1. You need to remember that, hey, it's quadrant 2, I got to put a negative after I look up the, again, the old days, you look up the table, find the cosine of the reference angle is 10, you look at 10 degrees, but just you got to remember to put a negative in front. Because you're in quadrant 2. So they're not. Now, if it was 350, which is 10 degrees here and 10 degrees here, then the cosines would be equal because quadrant 4 and quadrant 1 have the same cosine SIGN sign. Right. Favorite commercial? I really like the sloths. Push it. Burrito sloth. You guys didn't see that? No. Did you see the one with the Uber don't eat? Or you didn't pay attention to what that's all I care about. Dr. Strange was Moon Knight was great. So trying to relate to you guys is like me trying to talk to a brick wall sometimes. I really pet my dog. We both like sweets. 13 to 29 are the odd. So you pick. If you wanted to see anything out of that set, 13, 14, 15, 16, 17, or 18, you're going to do 13 and 17. But I'll do any of those. Be quick. 13. So the picture's drawn for you. All you need to do is complete the triangle. That also helps. So if the coordinates are 4, 3, then you know the x down here below is a 4, and the height, the y coordinate, is a 3. That will help you figure out what the radius is. Now, if you're paying attention to the Pythagorean triples, if the legs are a 3 and a 4, this has to be a 5. Has to. If you're not sure, then it's just r squared is equal to 3 squared plus 4 squared. So r squared is equal to 9 plus 16. So r squared is 25. You take the square root. R is a 5. We want sine theta, cosine theta, tangent theta, cosecant theta, secant theta, and cotangent theta. Sine is y over r, so that's 3 this. Cosine is x over r, so that's 4 this. Tangent is y over x, that's 3/4. And you know, I didn't even bother to think about what my sines are. Am I in trouble? Because it's in the first quadrant, we're not in trouble. Cosecant, flip over the sine, that's 5 over 3. Secant, flip over cosine, that's 5 over 4. Cotangent, flip over tangent, that's 4 over 2. So 19 through 25. 19 is 7 comma 24. So what do you see there? Give me one of those. Good, 23. I like it. Negative square root 21 and a positive 2. Which I probably closed it. Was just like what I'm going to give you as that reduction pretty close. Again, making a quick sketch, you don't have to be perfect, just make a quick sketch so you get things right. You draw the triangle in the correct quadrant. What quadrant is that ordered pair? Quadrant 2. X is a negative. X is a negative square root 21. So square root 21 this way and a positive 2 up here. There's my negative square root 21, positive 2. So my triangle looks like this with the x-axis. This is the theta. Down here. Now, what I do is I don't want to plug in negatives if I can avoid it. I need to know the radius still. The y is a 2. This is a square root 21. The length of the triangle is a square root 21. When I do this, I'm going to go over here. All right, I'm in quadrant 2. Sine and cosecant are positive. Right now, I'm going to go, hey, cosine is going to be a negative. Tangent is going to be a negative. Secant is going to be a negative. Cotangent is going to be a negative. Because I've already paid attention to what quadrant I'm in. So my signs are going to be correct. I just got to get my right numbers in. R squared is equal to 2 squared plus the square root of 21 squared. You'd be surprised when people just plug in negative square root of 21 and try to square it, they mess it up. They do. R squared is equal to 4 plus 21, so R squared is 25. I work with the common theme. So the radius is going to be 5. It does not take a lot of time to just make a quick sketch. Make sure you're in the correct quadrant. So sine is the y, which is 2 over 5. The cosine is the x, so it's going to be negative is already there. Square root 21 over 5. And the tangent's going to be y over x. The negative is already there, 2 over square root 21. When you look at in the back of the book, it will be rationalized. So in the back, it's going to be negative 2 square root 21 over 21. The cosecant, flip over sine, 5 over 2. Flip over cosine, negative 5 over square root 21. Again, it's going to be rationalized, negative 5 square root 21 over 21. And the cotangent, I'm going to flip over that first one, negative square root 21 over 2. Definitely are going to see something like 27. $27.30. They want to know what quadrant is it. What quadrant is theta in? Based on those clues. I'm going to do the evens. 28. Secant greater than 0 and cotangent less than 0. Secant reciprocal of cosine. So if secant is greater than 0, this also means that cosine is greater than 0. If cotangent is less than 0, that means the same thing is going on with tangent. It means tangent is less than 0. Cosine is positive. It's basically process of elimination. Cosine and secant would be positive in quadrant 1 and quadrant 4. That's the only two choices right now, because that's what cosine theta greater than 0 means. And then over here, they're talking that cotangent and tangent are less than 0. They're saying that they're negative. Well, in quadrant 1, cotangent and tangent are positive. So out of these two choices, that is impossible. What are we left with? We're left with quadrant 4, and in quadrant 4, tangent and cotangent are negative. Cosine and secant are positive. So the only way that this is possible is quadrant 4. It's just process elimination. But you got to write down your clues. On 30, tangent theta is greater than 0. Cosecant theta is less than 0. Well, tangent theta is greater than 0, is positive. Everybody's positive in quadrant 1. Tangent is also positive in quadrant 3. So right now, that's my two possibilities. Now, here comes cosecant, which is the reciprocal of sine theta. So we're also saying that sine theta is less than 0. We're saying it's negative. We know sine is positive in 1 and 2. Sine is positive in 1. It can't be negative. It cannot be that answer. Sine is negative in quadrant 3, so the answer is quadrant 3. Okay. If there's really no work to show except drawing that picture, get your mind wrapped around. And again, even though I recommend drawing pictures, people don't do it. All right. On the warm-up I'm giving you today, you're going to see something like 31 through 38. Find all 6 trig ratios, given that information that you see there. And most importantly, not just the information you see there, but the constraint in the second column. The constraint is more important than actually doing it. And I'm sure, a lot of times, especially if you get to use notes, for some of these, you're able to do everything you can do. So, out of 31 to 38, you get to pick. Very 36. Sine of theta is equal to 0, and we are told pi over 2 is less than or equal to theta, which is less than or equal to 3 pi over 2. That's the constraint. That's the restriction on the theta. And we got to fill in sine of theta, cosine of theta, tangent of theta, cosecant of theta, secant of theta, and cotangent of theta. And you better not get this part wrong. Sine of theta, 0. What's the cosecant? Undefined. 7 tenths. Because if you take the reciprocal of 0 over a number, because that's what 0 is, if you do the reciprocal, you get a number over 0, and you cannot divide by 0. Okay, 0 in the denominator is verboten. 9 yet, we'll do it. So that takes care of 2. Pi over 2 is right here. 3 pi over 2 is opposite. It's down here. So here's pi over 2. Down here is your 3 pi over 2. Theta terminates somewhere between here to here. Somewhere in quadrant 2 to quadrant 3, somewhere between here, between 90 and 270 degrees. So right there. Sine is y over the radius. So in order to get 0, what would y and the radius is going to be, don't know what. But in order to get 0, what would the y have to be? The y would have to be 0 over the radius. That's how you get a 0 in your fraction. So the only time 0 is going to happen, the only time you're going to get an answer that's a 0 is on one of the axes. It's either on the x-axis or the y-axis. Y has to be a 0. Well, when you're on the circle right here, x is going to be anything you want, but the y coordinate on the x-axis is 0. When you go up here and you're at 90 or pi over 2, x has to be 0 because you're not going left or right, and the y is whatever the y is. When you go over here to 180 or pi, over here, the x is the opposite of that x, because you're going in the opposite direction. It's the opposite of that x, but the y coordinate again has to be a 0 when you're over here. And when you're down here at 3 pi over 2 or 270, the x coordinate is a 0, and the y coordinate is whatever the y is, but it's a negative y because it's down below. It's the opposite of that positive y. So where is the y 0 in that 0, or sorry, in that pi over 2 to 3 pi over 2 interval? Where's the y 0? At what angle? At 180. This is where your y is a 0. This is what they're talking about, right there. Okay. So now cosine. Well, technically, circles are made with what? What's this thing called? Radius. The radius, right? When you're here, that x coordinate, isn't it the same length as the radius? Yeah, that's the same length as the radius. When you're right up here, the y and the radius have to be the same. Right? So when you're over here, this is the radius of the circle, and this technically right here is negative r because it's a coordinate. It's a negative r value because it's a coordinate, y is a 0. So the cosine of the x coordinate over the radius is negative r over r. The cosine at pi radians, the cosine right here, -1. And at 0, this is positive r. So the cosine at 0 would be positive r over r. At 0, the cosine is positive. Does that make sense? Okay. The reciprocal of -1 is -1. The tangent is the y over the x. 0 over negative r is 0. The reciprocal of 0 is undefined. When you're at 90, the sine of pi over 2. Up here, x is a 0, but the y value is equal to the radius. The y and the radius are the same thing. So the sine of pi over 2 is the y over the r, and the y has to be the same as the r, so r over r, 1. The sine of 90, the sine of pi over 2, is 1. And the cosine of pi over 2 would be the 0 the x over the radius, so you get 0. Remember what I told you about complementary angles? One's sine is the other one's cosine. The sine of 0 is 0, but the cosine is 1. Cosine is 0. Up here, the complementary angle technically of 0 is 90. The sine of 90 is 1, okay? And the cosine of 90 is 0. So the sine up here, 1. The cosine down here is 1. One's cosine is the other one's sine. Okay. That's 36. 37, if cotangent is undefined, cotangent is x over y. If it's undefined, that means you have x over 0. That's the only way you get undefined. If you flip over cotangent, if you flip it over, you get tangent. So that means you flip over x over 0 and you get 0 over x. So when you flip over undefined, the reciprocal is 0. The tangent at this angle is a 0. So if you flip over undefined, you get 0. If you flip over 0, you get undefined. Now, that means y is the 0. And it's on that same interval that we did right here for 36. So that means we must be at pi radians, or 180 degrees. Tangent's undefined. If tangent's undefined, that means you have tangent is y over x. So it must mean you have y over 0. The only place where x is a 0 is down here or up here. That's when your x is a 0 at pi over 2 or 3 pi over 2. Angle theta is between 1 pi and 2 pi radians. It's between here's 1 pi and 2 pi radians. So they're talking about 3 pi over 2. That's the angle. So it's down below. And then here, 39, 101 odd. Okay, 39, 40, and 41, 39, 41. Let's just do 41, because that just, it'll be quick. It'll be more like, it'll just be the more difficult one out of 39 and 41. So that'll give you something to go back and look at. 39 left, it's a little bit more power. One of the hidden little interesting pieces about these trig ratios, they are so versatile. When you have an angle in standard position made by a line, I can give us a little bit of information about that. You can find all 6 trig ratios. Anybody else? The terminal side of theta lies on the given line in the specified quadrant. in the specified quadrant. Find the values of the 6 trigonometric functions by finding a point on the line. By finding a point on the line. I wonder if I can still remember how to graph a line. If I'm going to graph a line, I probably want to solve for y equals mx plus b. So if I have 2x minus y equals 0, then I'm going to subtract 2x from both sides. So I can get y by itself. That's a negative y. On the right-hand side, 0 minus 2x is negative 2x. And I'm going to divide by negative 1 because I want to know what positive y is. So I get positive y is equal to negative 2 divided by negative 1, positive 2x. So when I graph this, I now have slope-intercept form, y equals mx plus b. My slope is a 2. My y-intercept, what's the plus b that has nothing right here? That's a 0. There's a just 2x and there's nothing after, there's no constant. That's because there's a plus 0 that basically simplified away, which means the graph goes through the origin. That's the first point I'm going to plot. It's on the origin. That's the y-intercept. From there, I'm going to count the slope. For my slope, I need rise over run. So as a fraction, 2 is 2 divided by 1, 2 over 1. So I'm going to go up 2 and then over 1. The direction said, find all 6 trig ratios by finding a point on the line. Oh, I went up 2 and over 1. I just found the next point on the line, x is a 1 and y is a 2. Finding a point on the line. Now, if I was fortunate enough to be teaching in a rigorous private school system, I could walk around the classroom with a ruler right now and hit myself over the knuckles because I'm about to get this wrong. Because I'm totally neglecting quadrant 3. I put that point 1, 2 in quadrant 1. When they told me I'm supposed to be looking at quadrant 3. This angle is not in quadrant 1, it's in quadrant 3. Okay. Guess what? 2. Yeah, that's 2 over 1, but I could also go negative 2 over negative 1. That's the same as positive 2. Okay, because look, you can see the lines in quadrant 3. So that means I'm going to go down 2 and to the left 1. So that point right there is at negative 1, negative 2. And this is what the angle actually looks like. That has nothing to do with it. It terminates on this line going that way. There's my right triangle. Now, I'm always going to put positive numbers when I make my triangle. The x right here is a 1. The y right here is a 2. I need the radius. The radius squared is equal to x squared plus y squared. So my radius squared is equal to 1 squared plus 2 squared. So my radius squared is equal to 1 plus 4. So my radius squared is a 5. Take the square root. The radius is the square root of a 5. because we know we're in quadrant 3, I could have even already done here. Sine would be negative, cosecants are negative, cosines are negative, secants are negative, and tangent, cotangent have to be positive. I could have already done that. So now I have my x. Now remember, I already took care of the negatives. So 1 over square root 5. Right, 1 with sine 30. The y is a 2 over the radius square root 5. Cosine is the x, which is the 1 over square root 5. And the tangent is the y, 2 over the 1, which is simplified just 2. The cosecant is negative square root 5 over 2. The secant is negative square root 5 over 1, or this negative square root 5. The cotangent is the reciprocal of 2, which is 1/2. And if you rationalize these over here, this is negative 2 square root 5 over 5. And this is negative square root 5 over 5. Okay. The slope gives you that point that you're going to get on the line. Okay. And realize the slope was down to left 1, but the ordered pair, the x is the 1 and the y is the 2. When I teach this when I used to teach it in the regular algebra 1 class, they would put 2, 1 because they did the 2 first and the 1 second. So they were 2 and 1. Even in algebra 2, they would put the 2 and then the 1 first. So be careful. So, so if we have this out, the next step. Piece of cake. But again, on a test, you don't get to have the unit circle. And it says, evaluate the trigonometric function of the quadrant angle if possible. Now, the quadrant angle means it's on one of the axes. You know, so even if you just visualize, even if you just visualize, 43. Pi is over here. Okay, so right here, pi. You know that r and x are the same. So this would be r over and y is 0. Secant. Well, I have no secant, I'm going to do cosine theta. So that would be r over the radius is r. But on this side, my bad, to the left, x's are negative. Therefore, secant theta is -1. And I know I just went through that very quickly, but that's the breakdown that my brain is trying to go to. It's on the left-hand side. X is negative on the left-hand side. So anything that deals with x is going to be a negative thing. If it's cosine. Now, tangent would be y over x, so tangent's positive. Because it's on the x-axis, the radius and x are the same thing. Cosine's 1. 3 pi over 2. First of all, you need to know that 3 pi over 2 is down here. This angle. When you're here, X is a 0, and Y is the opposite of that Y up there, and it's going to be the same length as the radius, so technically it's negative R, whatever R might be. But we want secant, so I'm going to do cosine first. Cosine is that X over R again, so that's 0 over R. So the cosine at 3 pi over 2 and at 90, because up here at 90 pi over 2, X is 0 on the y-axis. So at either one of those angles on the y-axis, cosine is always 0. That means secant theta is going to be undefined. And that's what they mean by if possible. If possible, you didn't find an answer, but you still have to write undefined. That's what you're doing here. And then you're doing these angles, 120, again, radians and degrees. So I just want you to find the reference angle and sketch it. So 120, the reference is this one, so that would be 60. Sketch it right there. Theta prime is 60. So you're going to sketch this, your 120, and then sketch that. 455, and we did this in the warm-up. Negative 45 degrees. So here's your negative 45 degrees going into quadrant 4. So theta is negative 45 degrees. So your reference angle, well, I'm sorry, the 120, the reference is over here. Here's your theta prime in quadrant 1. So for 55, your reference angle is this one, 45. That's your theta prime. Negative 5 pi over 6. What quadrant is negative 5 pi over 6? Which one? 2? No. 3. First of all, 5 over 6. 5, 6, that's less than 1, right? If I'm going in the clockwise direction because of the negative, this would be negative 1 pi. So 5, 6 is less than that. So I'm going to stop short. Okay. Now, positive 5 pi over 6 is up here. So negative 5 pi over 6 would be that reflection down here below. So here's where your negative 5 pi over 6 is going to terminate. Okay. So the reference is this guy right here. So if that's 5, 6, then that would have to be 1, 6, 1 pi over 6. So the reference angle, theta prime up here, is 1 pi over 6. Okay. Does the visual on that circle help? I mean, for me, that's how it helps me. I don't do the in my head adding, subtracting very well because I know the circle. I can do the in my head a lot better than before. I couldn't do it at all. Okay. I was fumbling around with pencil and paper, just adding and subtracting random numbers at them. Now that I understand that I'm supposed to think through the picture, I know exactly what I'm going to add or subtract. More sketching and reference angling. And I really like number 70 and 69 and up here, oh, that's all. So let's look at 70. Let's look at 69 and 70. So you're given angle theta. Find the reference angle and sketch theta in standard position and label theta prime. So 69 is the original angle is 1.8. Now is that radians or degrees? Because there's no degree symbol, correct? It's radians. What quadrant is it? Quadrant 2. So you know that 180 is the same as pi, right? Right? Pi is approximately 3.1415. At 90, that's pi over 2 radians. 3.14 divided by 2 is approximately 1.57 radians. That's where 1.57 is. Get used to the numbers. So if that's 1.57 and this is 1.8, then 1.8 is going to be right around here. So theta prime, the reference angle, is going to be it's going to be pi minus 1.8. You don't do 3.14, you actually use calculator and use pi. Okay, that's how you get your theta prime. For 70, if theta is negative 6.5 radians, what quadrant is that? Pi over 4. So 3.14. We know this is 2 pi. 2 times 3, that's 6.28 when you go 360, one revolution around. So when you do negative 2 pi, that's negative 6.28 right about there. So negative 6.5 is just a little bit further. Now, if it was going to be in quadrant, all the way to here, remember that's another 1.57 for another quadrant. Another 1.57 would take us, past negative 7 over here. So this piece right here would be negative 6.5. And basically, if you just add 2 pi to that, you'll get something in quadrant 1. Okay? Because it's negative. You could do, 2 pi minus 6.5, or let's do this one. 6.5 minus the 2 pi, and that'll give you this amount of opening, and it's just the same on the other side. So that takes us all the way through 7. So I will send you, like I said, handout with quiz-like. All right, Roger. Here. Josh Neha.
Here.
Pablo. Hello. Marcelino. Ben. Here. Lindsay. Here. Brennan. Here. Daniela. Isaiah. Here. Candace. Here. Chris. Okay. Have a good one. We'll see you all Wednesday. Don't forget, next Monday, no school.